You guys, we'll give you one more minute. All right, grade 9s, let's shut down on that website and please get, actually, before we do our notes, I don't think we've gone through our lesson 5 check for understanding. So this is the one that you did during class, that Google assignment that you did on, I guess it was Friday. Let's just take a look through. There's a few things I do want to point out to you. So this first one, you can just kind of look off on the side here and see the work that was done. This is a true or false question. So right now, kind of the question is, you know, does this really equal a to the 9th? So I'm just doing my exponent laws over here to find out that, yeah, it really does equal a to the 9th. So that is a true statement. And guys, please, anytime you have a question, just click your mic on and feel free to ask. Now, there were a few people that got caught on this one. If we were to do this one for real, you know, take a look at what's going on in this question. If we had 4 cubed times 4 to the 5th, the rule for multiplication is keep the base the same and add exponents. But notice they say that for adding, you also get a 4 to the 8th. Well, that can't be true. Adding and multiplying can't be done the same way. Those are different operations. So what's important to understand, you guys, is there is no shortcut rule. You cannot combine powers when it is adding or when it's subtracting. So don't get tricked up on those ones. And then this one too, I don't think that this one was a problem really for anybody, but just a reminder that our shortcut rules only work when the bases are the same. So if you take a look at these two powers, they have different bases. You cannot combine those into a single power. So that one is false. And then number 5, I had a typo on it when you guys did it, so I actually just excused it. We omitted it. So rather than your marking this out of 8, I just took that question off and marked it out of 7. And but just to look at the work here, you know, a lot of people in their work chose 3 to the 12th. And I think you probably chose that one because there wasn't a correct answer because of my typo. But let's just remember that standard form is like the answer. So standard form, we're looking for just your number. What is the value of it? Okay, for number 6, I showed actually 2 different ways that you could do this question. So over on this side right here, I did exponent laws, because we did have these 2 powers with the same base. So it is possible to do a combination there of those 2 powers. Over on this side here, I just did straight BEDMAS. I didn't do any exponent laws there. And what I want to tell you guys on this one is it's really about Google Forms more than it is about math. So on a short answer like this one was, where you're just supposed to type your answer in, these questions are kind of like numerical response questions on an exam. All you do is put the answer. And if you put anything else, if you type anything else in that blank, it will get marked wrong. So you might look back at your work that you put on Google Classroom and see that this was marked wrong because maybe you didn't just type the answer in. So I go through them manually before I release the marks, and I fix up any kind of weird typing or anything that's gone on. But we really are just looking for just the answer, which was 30. In number 7, I'm following BEDMAS, but at the same time, I'm using exponent laws. So I know that I'm supposed to work in the brackets first. So what I did in the brackets was I used my quotient of powers rule, where the base stays the same and I subtract exponents. So that got me to here. And now, like a brand new question, this question has multiplying and it has subtraction. So I'm doing this multiplying first. So again, I kept the base the same and I added exponents. Notice this little floater negative just hanging around out front. Nothing's been done with it yet. This is now a subtraction question, and there is no exponent law for a subtraction question. So this step right here, this is where BEDMAS kicks in. And so you can see that I did exponents first, and then I do the subtraction at the end. And again, guys, here we're looking for you to type in just your answer, nothing else. Okay, when we're looking at number 8, it's saying to us, if you did all this work, what would your answer be? Your answer is going to be x to the power of something, and we have to figure out what it is. So here's my work over on the side. There's multiplying and there's division, so I'm working from left to right. So I combined those powers to be x to the 8. And then I combine those powers to be x to the 6th. And so again, it says, what number would replace the question mark? So we had people typing in x6, but that's not really accurate, right? The question mark, what would replace the question mark is just a plain old 6. So we should be typing in just 6. Okay, number 9 is similar, but a little trickier. So here's how I started off with my work. I knew that I'd have to work from left to right. I knew this would be the first operation to do. But with that missing exponent, I can't actually do that operation. So I said, okay, whatever that is, when I multiply it with a -3 to the 1, that gives me -3 to the 7. So what I figured out was this box, what needed to be in that box is a -3. Whoops, -3 to the 6 is what would make that equation work. So I took apart those pieces and I went, how am I going to make this equal -6? to the 6. So I figured out the missing number was 7 because when we divide, we keep the base the same. And 13 subtract 7 is how I would get 6. So a tougher question. You guys did pretty good on that one, but are there any questions on that one? It was our most common mistake. All right, so guys, we got to finish off lesson 6, notes. So please go in your notes booklet and let's find where we left off on lesson 6. And I want to remind you about the 2 new exponent laws that we've already covered in lesson 6. All right, so the first one we did on lesson 6 is power of a power. It's when we've got a power, and that power is the base on another power. And we said the rule here is keep the base the same and multiply the 2 exponents. Okay, so take a look at our example down here, just to make sense of it. So that was one of them, power of a power. And then the other one we did was power of a product. So power of a product happens when you've got a product in the bracket. So this is a product because it means A times B. And that product is to the power of M, so it means that M applies to both parts of the product. And I want you to take a look. We'll make up one more example in here. Take a look at this one. Let's say we have 4n squared m cubed all to the power of 5. So in this product, we have 3 pieces. And that 5 that's on the outside, it applies to every piece that's in there. I want you to remember that the 4 has an exponent. It has that invisible exponent of 1. So here's how I can simplify this one. This 5 is going to be applied to every one of those exponents. And remember what we do, this is power of a power. This is where we multiply exponents. So I would have 4 to the power of 5, n to the power of 10, m to the power of 15. And I could simplify even further because I can actually calculate 4 to the power of 5. 1024, I believe. Maybe I better check. Not always so sharp first thing in the morning. Yep, we're good. So we'd have 1024, n to the 10, m to the 15. So that example is really showing us a combination of both rules. We've got a product, so that exponent applies to every piece. And we also have power of a power where you have to multiply exponents. All right, so I'm going to give you a minute here just to kind of review over the examples that we've already done, and then we'll jump in where we left off. All right, so you had 3 of these examples to do for homework, and I'm going to be calling on people to share their answers. And if you didn't understand it, that's okay. You can just say I didn't get it, and we'll go through it together. Ava, let's start with you. Tell me what you got for C, Ava.
Which page is this?
So this is in your notes booklet, and it's lesson 6. So we don't really have page numbers, but we're in example 2.
It's page 31.
Oh, we do. Well, thank you, Cole. My booklet does not. That wasn't Cole, was it?
Nope.
First C.
That was, who was that, a boss? I'm trying
Yes.
to look. I could see Cole was about to say it. And I was like, that's not Cole's voice. So Ava, did you find it? Example 2, question C.
Said 5 to the power of 2 times to the power of to the x to the power of 6 times y to the power of 8, and then you have 25 x to the power of 6 y to the power of 8.
You got it. Nice work. Any questions there, you guys? All right, good work, Ava. Let's have a look at the next one. So example D, Liam Byrne, tell me what you got here.
I didn't get this one. I was really confused.
Okay, let's have a look at it. So this is, it's not only power of a power, because you can see we've got these powers that are raised to another exponent. So that's power of a power, but it is also power of a product, meaning that this 2 on the outside is going to multiply every exponent on the inside. So we'd start off with 2 to the 6, x to the 6, y to the 4. And then we can take it one step further. That 2 to the power of 6 can be evaluated, and we get 64 x to the 6, y to the 4. Guys, any questions on that one? Can I see thumbs up if you got that one right, please? All right, looking good, guys. Let's take a look at E. Austin, what did you get for E?
Like explain it, right?
Yeah.
So I had -3 to the power of 3, x to the power of 3, and y to the power of 12. And then I simplified it to -27, x to the power of 3, and y to the power of 12.
Good job. So one of the things that can be tricky here is that negative. So I'll tell you what I do when I'm thinking about these ones. I think about how in the brackets I have 1, 2, 3, 4 pieces. I treat that negative like a separate piece. So I think to myself, a negative to the power of 3, which is odd, will still be negative. And then I move on to the 3, and then I move on to the x and then the y. So kind of treating that negative like it is a separate little piece. All right, so those were your practice questions. And now here's your bigger practice questions. So guys, we're into work time. So in our textbook on page 84, and I've written out some instructions here. So I feel like we better take a look at those questions. Perhaps I changed our instructions on them. So everybody get to page 84 and let's look at number 6. Yeah, number 6 says write as a power. And I think I'm just, trying to get the point across there that we're writing it as a single power. Right now it's a power of a power, but we want just a single power. And then for number 10, where it says simplify each expression, then evaluate it. So simplified meaning apply any exponent laws that you can, and then do BEDMAS to figure out the answer. But that whole simplifying each expression is kind of like saying apply the exponent laws first and then evaluate. So guys, we'll give you, I think ample work time here. We'll see sort of how we're doing in a few minutes, and we might get started onto the next examples as well. How we doing, grade 9s? Remember, you can ask a question anytime and check your answers as you go. Jarek, did you have a question?
Yeah, I did. For number 12.
Number 12, just let me get to it here. Okay, so do you want me just to kind of go through comparing those ones?
Yeah, yeah.
Sure. Hey, let's have a look. So for number 12, it says compare the values of, so it gives us negative 4 squared to the power of 3, and then negative 4 squared to the power of 3. It's funny how when you say these out loud, they all sound the same. So again, negative 4 squared to the power of 3. So when you say them out loud, they sound the same, but when you see them on paper, they're written differently. And then to figure out, what they mean, I think the easiest thing is to kind of pick them apart sort of piece by piece. So if we were to look at this one, I'm going to put it in expanded form because that kind of explains what is going on. Remember that this 3 is only working on whatever's right in front of it. So that floater negative is just like a -1. It's not part of the base. The base is 4 squared, so that's going to be repeated 3 times. So that's what that one means. If we put it, Don't know why I put that one out there. Let me fix that up. If we put it in expanded form, it kind of shows what it means. And it also, I think, explains why the answer comes out the way that it is. So I'd still have my floater negative sitting there. And then those 3 powers are multiplying. So I'm going to keep the base. I'm going to add the exponents. And so if I was to evaluate this now, I would have, so 4 to the power of 6 is 4,096, but it's also being multiplied by -1, so there'd be a negative in front of it. So this is kind of the way that you can sort of compare what they mean. This one right here, the base, everything in the brackets is the base. So here we'd be looking at -4 squared times -4 squared times -4 squared. And so picking this apart even more, because it is kind of a weird one where the negative is in the bracket there, but when I look at this piece right here, what's happening in there is, this is what's going on. It's like a -1, and then there's a +4 being repeated twice. And so we'd have that for each one of these powers. It's like a -1 and a +4 being repeated twice. And I'm running out of room. But if I looked at all of this stuff here, so I would have -1 is being repeated 3 times, so -1 to the power of 3. 4 to the power of 1, 2, 3, 4, 5, 6. And then I'd say, okay, so a -1 to the power of 3 is still negative. And then I would do the 4 to the power of 6. And I see I actually end up with the same value as the first one. But when we see that expanded form, how we got there is a little bit different. So I think what I'll do is I'll leave kind of the last one for you to do there, Jarek. So think really carefully about what does the expanded form look like, and then you can compare it to the others. And the expanded form might look different, but we still get the same answer. Or it might look different and give us a different answer. So go ahead and try that third one, just kind of doing what I did on the first 2, and see what you think.
Okay.
And grade 9s, can I see thumbs up for people who are done the practice work? Okay, so just so you know, there's only about 3 or 4 people done, so we still have some more time. You guys who are done, you might want to head back to that little website with the Number Sense Fun. Pick up where you left off and keep working at it. Austin, did you have a question? Your hand is up. No? Okay,
Sorry, I forgot to put it down.
that's okay. Guys, can I see thumbs up for people who are done the practice work? All right, that's looking good. So I think what we're going to do is maybe just do a couple more examples just to get us a little further into the lesson here. I don't know if we'll get to the point where we'll have other practice work, but we can get through a little more on lesson 6. So back to our notes, everybody. So, you know, we had that law called power of a product. We can also have power of a quotient. So remember, quotient is that word that means you're dividing. And so it's kind of the same rule. When you look at what we did with power of a product, we said the exponent applied to every piece of the product. And now with a quotient, we're saying, yep, same thing. That exponent is going to apply to every piece of the quotient. So if we take a look at this first example, it shows you what it would look like to take this. I know it just looks to you like a fraction raised to a power, and we see what it looks like in expanded form. But remember that fraction is really the same thing as 5 divided by 6, all to the power of 3. And that's why it's called power of a quotient rather than power of a fraction, because we look at it as division. And so if we took a look here, now think about how fractions multiply, how you multiply straight across the top and straight across the bottom. Well, in the numerator, you would have 5 cubed, coming from 5 times 5 times 5, and in the denominator, 6 times 6 times 6 would give us 6 cubed. And so what we see really is our little shortcut rule is take this 3 and apply it to both parts of the quotient. Okay, so let's take a look at some examples here. So for this first one, I'm going to again apply an exponent law to make this go a little faster. The long way, I'm only going to show one more time, would be like this. That the base is 2/3 and that it's being repeated twice. And then I would use my rules for multiplying fractions, and I'd multiply straight across the top and straight across the bottom. Now, we don't really feel so much like we're getting an answer or finishing a question. To me, this one just feels like a different form. You know, taking it from this form and putting it in this form, I'm not really sure that one is more simplified than the other, but just understanding that there's sort of 2 different ways to write that. This one I'm going to take just a little further for you. So let's take that 3 and we're going to apply it to both parts of the quotient. So this would be 4 cubed over 5 cubed. The one thing that this does is it does maybe make it easier to evaluate. So if this was a question where I was evaluating, it's probably easier to look at it as these 2 separate powers. So I could figure out, well, what is 4 to the power of 3? And I think that's one that we probably should know by now. So 4 to the power of 3 is 64. And same thing with 5 cubed. I think that's a number we already know. And so to me, it makes it a little easier. Rather than having to work with a fraction as your base, it's kind of like you're breaking it up into 2 powers. Like this one would be -3 squared, which is easy to deal with, over 2 squared, which is also easier to deal with. So it's like breaking it apart into 2 powers that are easier to work with than a fraction. And so -3 squared, that would be +9. And 2 squared would be 4. So that step just makes us realize, I think, that, we're not even really dealing with a fraction. We're really dealing with 2 separate powers. And for some reason, that seems to make it easier for our brains to handle. So here we're going to write down our exponent law for a power of a quotient. So a over b to the power of n is equal to a to the m over b to the m. And then in the next one here, noticing on the inside that there's powers on the inside. So now we've got power of a power. This is where we'll multiply exponents. And so I'd have a to the c times m over b to the d times m. And guys, if we were working with variables, you wouldn't even really see that multiplication sign in there. It would just look like this: a to the cm over b to the dm. So rather than working with this fraction, this allows you to work with 2 separate powers, which might just sort of feel easier than working with a fraction. Okay, so we're going to try that out. Let's see, how's our time here, guys? I just want to make sure I leave some for you guys to try. Let's have you try these 3. What the heck? I think you know the rule, and it's not that hard to evaluate. So it says, let's say you're going to simplify it as much as possible. Let's see how far we can get on these 3. Okay, so let's see how everybody did on the first one. Cole, tell me, how do I write this one in simplest form? Cole, what do you think on that first one? Is your mic, are you having problems with your mic?
Can you hear me now?
Yeah, I can hear you now.
Okay. A to the power of 2 and b to the power of 2. Oh, a to the power of 2 over b to the power of 2.
There we go. So it just makes it easier to work with, right? 2 single powers rather than a fraction. Liam Borman, what about the next one? What do you have for simplest form there?
A to the power of 6 and B to the power of 4, like over. A to
Good.
the power of 6 over B to the power of 4. Yeah.
Nice work. Any questions there, guys? Okay, and then I'll let somebody volunteer. Anybody want to show off on this last one? No one wanting to show off. So let's do this one together. Remember that this 2 on the outside is going to apply to every single piece that's on the inside. And also remember that right now this 2 has an exponent of 1, and so does the 3. So our rule here on power of a power is we're going to multiply exponents. So in the numerator, I'll have 2 to the power of 2, x to the power of 4, y to the power of 6. I want you guys to do the denominator. So take that 2 on the outside and apply it to everything in the denominator. So we'd have 3 to the power of 2, c to the power of 8, d to the power of 2, e to the power of 16. Any questions there? Now, because we've got some numeric bases, we should always actually evaluate when we have numeric bases. So it's not really considered simplest form to leave them as a power. So 2 to the power of 2 is 4. So I'd have 4 x to the 4, y to the 6. In the denominator, I'd have 9, c to the 8, d to the 2, e to the 16. So it started off, I think, looking fairly complicated, but when you start breaking it down just piece by piece, it's actually not too bad. All right, so guys, we are going to call it done right there. I just want to remind you that we're looking at our exam next week. I think it time lined out to be Wednesday next week. So just, you know, reviewing back, this whole every second day means it really stretches out over a long period of time. So looking back at old notes, old assignments, just to try to stay fresh with it. Finish up that practice work that we were working on, and we'll pick it up here, finishing off lesson 6 on Thursday. Any questions before we sign off?
Yeah, how much is our exam worth? Like the percentage wise?
It is just like your, if you had, you know how in unit 1 we had 2 exams? Those 2 exams together would equal this 1 unit exam. So it's what we would call just a normal weighted unit exam, but you haven't really.
Yeah, what's the weight of it? Like what's the percent of it?
I wouldn't be able to tell you just off the top of my head, because our categories each have a percent and our exams each have a percent. But you can look back at your outline where we have all of our breakdowns of our categories, and that might help you out a bit. Okay, so we'll leave with stay strong, be kind, and do your crazy dance. I'll see you guys on Thursday. I'll stay logged in here right till the end of class. So if anybody wants to stay with questions, feel free to stick around. I will be here.